Okay, so I'm going to be going through this 2012 AP problem. I believe it was on both the AB and BC tests, and this is number 5. Okay, so the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, it weighs 20 grams. If B of t is the weight of the bird in grams at time t days after it is first weighed, then dBdt, which is the rate of change of its weight with respect to time, is 1/5 100 minus its current weight. All right, so this is interesting because this matches very close. I mean, this matches exactly what the words say, and try take a minute to appreciate what this is telling you. It is proportional, so that means we're going to have a constant of proportionality, which in this case is 5, or 1/5, sorry, is proportional to the difference between its adult weight and its current weight. So this 100, that's going to be its adult weight. So what we expect is that once it gets to weigh 100, and look at that exactly. Once it weighs 100 grams, so if you put 100 in there, dBdt is 0. So, it tells you exactly the rate of change of its weight. After it weighs 100 pounds, it's not going to get any heavier or lighter, which is, the same thing as saying that the rate of change of its weight is 0. And so even though you don't necessarily need to understand that to get through this problem, it's interesting to stop for a moment and appreciate what this differential equation is telling you. And the differential equation itself tells you a lot, even if you have no idea what its solution is. And just on a side note, it's interesting also because you have dBdt. This is your dependent variable. Time is your independent variable. But the derivative with respect to time is a function of the dependent variable. So instead of having like dBdt equals some function of t, you have dBdt equals some function of b. And in case you're interested, when you have that, it's called an autonomous differential equation. When you have the dependent variable as a function, as the variable when you're dealing with your differentiation. Okay, so A says, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So gaining weight faster. So we're going to look at its rate of change of weight, which is by definition dBdt. So let's look at dBdt at time equals, or sorry, not time equals, that's the autonomous part, at b equals 40 and dBdt when b equals 70. So now we're just going to plug numbers in here. And the fifth is always going to be the same. So now we basically need to look at which of these scenarios makes this middle term bigger, since, if you multiply something by 1/5, the bigger one's still going to turn out bigger. So 100 minus 40 equals 1/5 100 minus 40. And here it's 1/5 100 minus 70. Well, 100 minus 70 is 30. 100 minus 40 is 60. So clearly this one is larger. And that allows you to say that this one is most certainly greater than this one. So it is gaining faster. It is faster when b equals 40. It's gaining weight faster when b equals 40. And we don't yet know what time that is at, because this equation is given to us in terms of b. And your reasoning would basically be that this would be your reasoning right here, that dBdt at b equals 40 is greater than dBdt at b equals 70, and that's more than enough. All right, that's exactly enough to get your point across. All right, find d squared b over dt squared, the second derivative of b with respect to time, in terms of b, which is what we already have here. Use d squared b with dt squared to explain why the graph of b cannot resemble the following graph. Okay, so what they're doing here, they're giving us this graph here, and they're saying that this is b of t. But what they're saying that the actual graph cannot resemble this. So we're going to find some information about the second derivative of b with respect to t, and then with that we're going to probably do some analysis of things like concavity or the slopes at certain points, and try and reach our conclusion of exactly why this is impossible. So we have dB dt equals 1/5 100 minus b. Now I'm going to take the derivative of both sides with respect to time. I'm going to get d squared b for dt squared equals, all right, so 1/5 times 100, that's just 0, and minus b with respect to time, it's minus dB dt from our chain rule. And if that seemed a little funny, you could also just turn this into, dB dt is also equal to 1/5 of 100, which is 20, minus 1/5 b. And then if you take the derivative of that with respect to time, you get negative 1/5 dB dt. Well, okay, so we have our second derivative in terms of dB dt here, but we already know what dB dt is. This is dB dt. So d squared b over dt squared is minus 1/5 times this, 1/5 100 minus b. Okay, so that's interesting. Negative 1 over 25 times 100 minus b. And that form should allow us to do some analysis here. Okay, so our second derivative tells us the concavity of the function. If the function is, if the function is, if d squared b over dt, if the second derivative of b with respect to time is positive, then that means the function is concave up, and if it's negative, it's concave down. All right, well, and remember this is in terms of b, so our intervals that we're looking at are going to be along this axis, which is kind of odd, but that's how it works. So if we plug in something like 20 here, we're going to get, so d squared b over dt squared at b equals 20 is equal to negative 1/25 times 80, which is negative, which is concave down. The problem is, well, I'll put in one more just to convince you a little further. If we plug in something like 30, that is also the case. We're going to get a negative number. If you plug in anything up to 100, it's going to be negative because of this negative, and that turns positive, which is saying that this function is concave down on its entire interval. This function here is not concave down on its entire interval. This section here is concave up, and they put an inflection point here. So, in short, this cannot be the graph because d squared b over dt squared is less than 0 when b is less than or equal to 100 and greater than or equal to 20. So on this interval here, on this vertical interval, it's always going to be negative, where here they had it positive, so this is impossible. And finally, part C. Use separation of variables to find y equals b of t, the particular solution to the differential equation. All right, so we're going to separate variables here and use that to find our solution. All right, so I'm going to start by rewriting this here. Well, there's no, well, okay. So this is part C, and I'll do it in a different color. dB dt equals 1/5 100 minus b. So we need to separate our variables here, and so we're going to get dB over 100 minus b equals 1/5 dt. or I'd say preferably, for the sake of simplicity in the future, 5 dB equals dt. The end of that section equals that section. Just multiplying that 5 over to clear the 1/5, and it makes it a little nicer to deal with. So then I'm going to integrate both sides, and we get on the left 5 ln negative 5. I'll explain in a sec. Ln of the absolute value of 100 minus b. Okay, this is negative because when you do your u substitution, I assume you can do these types of things in your head by now. It's 100 minus b, not b minus 100. So when you substitute, your du would be negative dB, and so you need to correct for that negative by sticking a negative out in front here. If that was confusing at all, you should probably go back and review u substitution. Equals t plus c. We could have added this arbitrary constant to the other side too, but it's kind of implied that when you add it to both sides, you can just combine them onto one side for now, at least. All right, so we're trying to find b. Okay, so now what we're going to do is divide both sides here by negative 5. There might be more than one way to get through this, but this is what I feel is the easiest way to do this. Ln of 100 minus b. Oh, and the other thing is that we already determined that b is always going to be positive, and b will always be less than 100 because it can't get to a weight past 100 because it's its adult weight, and so we don't have to worry about having a function undefined here because the ln is negative, and so at this point we can go ahead and make the decision to take down those absolute value signs and replace it with some nice parentheses so that we don't have to worry about going outside the domain of our function. And so ln of 100 minus b equals negative t over 5 plus some other constant, c sub 2, since you're dividing it by negative 5. Then we're going to take we're going to take both sides to the power of e, which might seem rather arbitrary, but e to the ln of something is just that something. So then you get 100 minus b equals e to the negative t over 5, and you can just rearrange that c to another c sub 3 here, multiplied. The logic there is that e to the a plus b equals e to the a times e to the b. In this case, it's e to the c, since that's our constant, and e to the c is just another constant, so you can just multiply another constant in front. That's a side note, but it's just the easiest way to set up something like that. And you can't tell that's a 5 at all, so I will rewrite that 5. All right, and then b of t is going to equal 100 minus c sub 3 e to the negative t over 5. So we have our solution, our general solution, in the form y equals b of t, since that's what it's asking for here. And then we need to solve for our constant. They say b of 0 equals 20. So when t equals 0, so if you plug in a 0 here, that's going to 0. E to the 0 is 1. And b of 0 is 20. So you're going to get 20 equals 100 minus c sub 3 times e to the 0, which is 1. And 20 equals 100 minus 80. So c sub 3 is 80. And our final solution, which I will write up here in a nice blue, and I'll make it even a little bigger. Our final solution is b of t equals 100 minus 80 e to the negative t over 5. And that's how you solve that autonomous differential equation, to look at the rate of change of a weight of a bird. Hopefully that was helpful, and see you in the next video.